Welcome back. This is going to be for AP Environmental Science, Unit 6. This is Section 9, all about hydroelectric power. We're going to look at the renewable resource of hydroelectric power and its many forms and sources. So the first source that we could actually get is called run of the river, where you retain water behind a low dam. You don't have any reservoirs, so it's not the traditional dam like in Lake Tahoe. There's a dam that releases into the Truckee. The reason that you do this is because there's not as much flooding. The river flow is typically not as disrupted. Of course, drawbacks is that this is on a smaller scale, so you're not going to produce as much electricity, and it's not quite as predictable because the water source might not give you the water you need all the time. Another source of hydroelectric power are hydroelectric dams. This is water impoundment. The largest reservoir is the Grand Coulee Dam in Washington. The largest dam is actually in Three Gorges Dam, which is the Yangtze River in China. And then the third type is tidal systems, where you actually use the power coming in from a tide to produce electricity. It is actually very efficient. 80% of the energy is converted. The problem is it does not have a potential as a major energy source because, for the most part, the tidal difference isn't big enough in most places. It is being used in France, Korea, and Canada, but what you're doing is you're essentially taking in the power of a tide to turn this little turbine and generate electricity. You need energy. Now, what's nice is as the tide comes in and as the tide goes out, you're going to be able to collect energy. So this just shows you the tidal changes throughout the world. So you can see if we were able to collect tidal power here, which is actually where Canada does theirs, there are larger changes. But if we wanted to, for instance, do tidal power, we would have to do it in the Pacific Northwest because it would be higher up here. But you can kind of see that there's not a whole lot of red areas that are easily accessible for us. And that would be, we'd need the red areas to be the spots where we would be able to feasibly get tidal power as a source. So these are some of the benefits and the downsides to building a dam. We'll look at the benefits first. One of the nice benefits of building a dam is that you can have water for year-round irrigation of cropland. As you build near here, you're always going to have a source of water. It can also provide a source for the water that you would drink. The reservoir is typically used for recreation and fishing, and you can get electricity cheaply because hydropower does not require a whole lot of money to make it happen. It also can reduce flooding downstream because you are able to control the water flow out of the dam. Now, some of the, of course, drawbacks. You have to flood the area when you dam it because there's no point in damming an area that's not going to flood, or else you won't have enough water to really have a feasible amount of electricity. You also lose more water through evaporation because the water is now just sitting and it is more likely to be evaporated by the sun. There are also nutrients in this water that were originally coming downstream and providing downstream sources of their nutrients, and now with building the dam, those nutrients are not able to get downstream, which deprives downstream cropland and estuaries. There's always a risk that the dam will fail. If the dam fails, you're going to have devastating flooding, and it can disrupt the spawning and migration of fish because it stops them from being able to travel either upstream or downstream depending on which way they were trying to go. This is the basics of a hydroelectric dam and some of the parts of it. So we'll look at all of these different parts, but this is the dam itself. The reservoir sits behind the dam upstream. The dam itself stops the reservoir from moving, and we are then able to concentrate the flow in the intake. The intake then goes into the turbine, which spins that turbine. The turbine spins into the powerhouse where the electricity is then generated, and that electricity is then able to be transmitted through power lines to the grid. So this is an example of the Colorado River and all of the dams on the Colorado River. So you can see the dams are in this little green here. So there's a dam here, there's a dam here, there's the Boulder Dam here, another dam down here, another dam here, another dam here. The upper basin of this watershed is this orange area. The lower basin is this area down here. And then there have been aqueducts created to transport water to Southern California and southern Arizona to provide those cities with drinking water. Another case study we're going to look at is China's Three Gorges Dam. The dam itself is actually 2 kilometers long, and it is able to produce the amount of electricity as 18 large coal-burning or nuclear power plants. Of course, when this dam was placed, it had to dam the river, which flooded upstream and displaced 1.2 million people. Another big risk is that they built the dam over an area that was seismically active and has already seen small cracks. And we've seen direct relationship with this dam being built to erosion and sedimentation and flooding downstream as the water flow becomes somewhat unpredictable. Now, some things that have been put forth some ideas that have been put forth is removing dams completely. The idea to remove a dam to restore the area. Removing the dam, maybe it's good, but it's probably better to not build the dam in the first place, because when you remove the dam, you can restore the habitat. The idea of that dam failing someday, if you remove the dam, you can do it in a controlled manner, and you remove the danger of that structure failing. And ultimately, you can restore the spawning of fish, the ability for fish to migrate. Some of the issues, of course, with the dam removal is that because of when the dam was built, there could be a change in the flow direction, so it might not actually take the flow that it once did. There's also legacy sediment, which could be contaminated with metal. So the idea is that you have all this sediment that at one time was flowing downstream. It has been trapped behind the dam. So behind every dam, there's this huge amount of what's known as impounded sediment that was at one time traveling downstream. And one of the risks of removing this dam is that all of this sediment is going to move. You also notice the temperatures are different, so you've actually created new ecosystems, and there's going to be a huge amount of fluctuation if you remove the dam in the process of this getting back to an equilibrium. So that is the end of section 9, all about hydroelectric energy. Our next video will be about geothermal energy, and I believe we're also going to do hydrogen fuel cells.